So I apologize for that. My internet just went out. I don't know if it's my internet or my computer even. So I'm going to finish up. So we're going to bring out, and I'll post this for everyone to see. So we have our partition. We're going to have a sum based on our partition, because on our partition, we had these very particular elements, very particular endpoints. And every time we choose these differently, we'll keep the endpoints the same, but we choose these other ones differently, we'll end up with a different partition. And this partition could be giving us subintervals of different lengths. So one of the grand questions is, it would seem that if we change our partition, we're going to get a different value for our sum, because it'll change the CKs that we choose, it'll change the delta XKs. But where this is going to work out is, initially you're correct. That would be correct. Different partition, we'll get different delta XKs, different CKs, different values of the function then, along with the different delta XKs. So that would change the sum. But as we increase into infinity, what we're going to have is a situation where it actually doesn't matter which partition we use. As n goes to infinity, we're going to get the same answer for our sum. So let's go back to our delta x. So remember, delta x was b minus a over n. And we're going to let the CK that we choose be called XK. So what we're going to get is A is x0. We have our x1, x2, and then xn. But now these are going to be the same width again. These intervals are going to be the same width. But we can describe this now as a plus 1 delta x. This here will be a plus 2 delta x's. 1 delta x, 2 delta x. So again, we're dealing with the same width here. And then this one here is going to be a plus n delta x's. Now you might be wondering, well, what's the point of bringing in k's if everything's the same width? Well, we are going to bring in the k's. They are going to be useful. So what this is going to give us, remember what delta x is. It's b minus a over n. So we replace delta x with b minus a over n. And same here. And what we're going to do, again, we're going to call these endpoints our C value. So that'll be C1, C2, Cn. And we could call this x sub k if we want. This would be, again, our x1, our x2, and this is xn. Which works out, because that's exactly what these points are. x1, x1, x2, x2, xn, xn. So what we're going to get is this, generically speaking. C sub k is equal to k. K is 1, k is 2, dot, 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 dot. K is n. C sub k is k times b minus a over n. So now let's go back to our Riemann sum. So we have, now we're going to refer to it not as a partition, because we didn't do that kind of random partition. We did b minus a over n. So we're going to refer to this by the number n of rectangles. We have k is 1 to n, fck, delta xk. Now, in this situation of delta xk, we now made them all the same width, delta x. So delta xk is just our typical delta x, b minus a over n. And then ck is k b minus a over n. So now our Riemann sum becomes k is 1 to n. F, now we replace ck with k b minus a over n times our delta x, k, which is just delta x, or b minus a over n. And so that is our Riemann sum. Double check anything left to really do. That's gonna be it. So if you have any questions about this, let me know. Otherwise, now let me check one thing. Oh, I forgot ck. I made a mistake on ck. Let me go back. I forgot something with ck. Ck, and this is what you want to change your notes up above too. It's a plus k b minus a over n. That's your ck. So let me go back and make sure that's there. But if you recall on your number line, you have a, b, we have a plus 1 delta x, a plus 2 delta x, a plus n delta x. So this became a plus 1 b minus a over n, a plus 2 b minus a over n, a plus n b minus a over n. And so this here was our C1. And again, we're choosing our C points to be the end points of these intervals. There's our Cn. And so what we'll actually get is C sub k is A plus k b minus a over n. I think I forgot to put the A plus. It's not just this, it's A plus. And so what that does to our Riemann sum for n rectangles, we'll have k from 1 to n, f of ck, which is A plus k b minus a over n times b minus a over n. And so this will be our Riemann sum. And that's going to be it. So any questions about this, let me know. We'll get into the 5-3 definite integrals, and then the fundamental theorem of calculus. And let's see, hopefully we'll get into the substitution method. We'll try to wrap up chapter 5 next week, and we'll go from there. So other than that, have a wonderful weekend. Let me know again if you have any questions. And well, have a wonderful weekend.